Hello, my name is Bob Tipton, and this is Dark Sky Innovative Solutions presentation on community sustainable ocean energy generation for Indigenous peoples. OroAzul is our systemic roadmap for turning fossil fuels into the fossils they should be and global sustainability. Achieving true sustainability requires economic, employment, and population sustainability with a projected life of at least centuries. That means a projected, sustainable economic advantage for all, especially developing indigenous peoples. Population and developing nations, the subject we must stop avoiding. Affluence leads to declining population versus for one group to prosper, another must lose, is the dilemma we are all facing. We are working at finding a win-win answer. Reducing poverty is more than ethics. Sustainability requires getting back within carrying capacity, and that requires declining population. It's conclusive that increased affluence and education, especially of girls, lowers fertility. If you look at this map, which is pretty representative of other world demographic maps, the magic number is 2.2. If each couple has 2.2 children on average, that results in a more or less zero growth population. So numbers 2.2 and below are declining, 2.2 and above are increasing. And if you look at a map of the globe, most of the developed world has declining population. The true areas of population growth are in the developing world, where we have a great deal of poverty. The Southwest Pacific Islands are crucial. Inside the little black loop on the right are the Southwest Pacific Islands, including Vietnam, Taiwan, Cambodia, which are the coastal areas where this technology also applies. And the total population in this region is about 540 million citizens. If they were one country, they would be the third largest in the world, right behind India and before the USA. And they are some of the poorest, and as you can see inside that group, they have some of the highest population growth. So part of our key is to not just collect sustainable energy, but to increase the income and affluence of this region, thus creating sustainable energy and reducing fertility and trying to get this region back within carrying capacity. This is an animation of the proof of concept we are trying to develop at our Bantayan test site. It works by closing a bunch of sails, which act as a net. That catches the current, which produces a great deal of force on this rope, which drives a generator. This stroke runs for quite a while. We're anticipating as much as possibly 100 meters on this stroke. And as it approaches the end, which should be right about now, it opens, releasing the force, and the motor drags it back into the starting position, and it is closed, and the cycle begins again. This is basically using a Raspberry Pi and a single stepper motor. We believe we can build one of these. It's comparable to a 3 to 5 kilowatt generator that you would buy at the local hardware store, all except that we have removed the gasoline engine. The gasoline engine usually accounts for 1/3 to 1/2 of the unit cost. So we believe that in mass production we can produce units like this for around $250 to $500. And if we can get them to last 10 to 15 years, that's how we're getting our cost estimates. We don't expect our final version to look like this, but this is the one that we're testing off of Philippine fishing boats, which are called bancas. Here's some snapshots from work we're doing at the research site. The handsome fellow in the middle is Joar Sevillano, who is our chief engineer for this project. When you see him here in local hot weather work garb, you don't really appreciate the fact that Joar is highly educated and was the chief electrical engineer on Dubai's new midfield air terminal. He's a native of the island and was stranded there during the pandemic And by a great stroke of luck, we were fortunate enough to cross paths. And he is probably even more emphatic about his belief that this system will work than I am. He's there day to day trying to get these systems up and running with the boat crews, working in, actually they're very comfortable conditions, but we just simply can't get supplies right now. We can't get boards, we can't get parts, we can't order anything. It can take us 3 to 4 months to order and have a circuit board delivered. So we're doing pretty much everything using local materials, which actually fulfills our mission, because the whole goal is, can we assemble and maintain these things using predominantly local talent, local materials, and what can be delivered to the island. So, a little bit about Bantayan Island. It's more or less in the geographic center of the Philippines. I imagine that very few of you listening to this have ever heard of the place. Getting there involves usually flying to Manila, flying to Mactan International Airport, crossing the bridge from Mactan Island to Cebu Island, taking a 2 to 4 hour road trip up the island to another port, Hagnaya port at the north, and then taking a 1 hour ferry from Hagnaya to Santa Fe on Bantayan Island. It's not exactly a well-known travel location. Bantayan has a population of about 130,000 people, and it's kind of a microcosm for the world. It has limited resources, a growing population, has job shortages, and it's located in a marine sanctuary called the Tanon Strait, with all the environmental restrictions that come along with that. The Tanon Strait has an area of approximately 13 billion square meters, with an average tidal range of 2 meters. If you multiply those two, one tidal cycle is about 28 billion cubic meters per cycle, and there are 4 per day. It goes up and down twice a day, so it's 2 up and 2 down for 4 cycles of 28 billion cubic meters. That works out to be about 112 billion cubic meters of water moving through 3 inlets. 1 at Dumaguete at the top of the image, and 2 down at Bantayan Island. We chose not to work in Dumaguete for logistic reasons, and because the currents down there are so strong that operating under those conditions is unsafe unless you have a much better equipped operation than we can afford at this time. Just for perspective, the entire Amazonian watershed only moves 20 billion cubic meters a day. That's the entire rainfall to the Amazon rainforest and what flows out through the Amazon River. So we are moving about 5 to 6 times as much water in and out of these 3 channels as the entire Amazonian watershed. If you apply conservation of energy methods to this, we work out that we get roughly 14 gigawatts of power flowing through these 3 inlets. Obviously, we won't collect all of it. The entire Philippines, 110 million people, consume 8 gigawatts. The Tanon Strait is just one of many such bodies of water in the Philippines. In this map of the Philippines, the red dot is Bantayan Island, and the little blue strip below it is the Tanon Strait. And as you can see, the Philippine Islands have dozens of entrapped tidal basins with 7,400 islands constricting the flow. And the Tanon Strait's 14 gigawatts are barely visible on the map. Each of these bodies of water, channeled through these small inlets and exits, are potential places to collect massive amounts of ocean energy. What we're looking at here is a map of the global ocean currents. I'm going to pause here, right on the Philippines. And you can see the Pacific Equatorial Current coming in from the right, crashing into Mindanao. And you can see that divides going south into Indonesia, Malaysia, and going north through Taiwan and Japan. It looks as if the Philippine waters themselves are pretty calm. And that threw us for a while until we realized that these large ocean maps are taken over weeks, months, and years, and as part of reducing it down to the image you see, they take averages, and those average out the daily fluctuations of the tides. So the ocean energy from the major ocean currents you see here and the tidal energy that we're predicting previously actually combine to make the the interior Philippine seas some of the most active bodies of water on the planet. So again, why are we on Bantayan Island? Once known as the Alaska of the Philippines due to its fishing industry, Bantayan Island now has about 3,000 unemployed or underemployed boat crews. The average fisherman earns about 250 Philippine pesos per day. That's about $5 a day. And gas for their boats costs about $7 a gallon. So yeah, it's costing more than a day's income to buy 1 gallon of gas to power the fishing boats. OroAzul's goal is to make use of these experienced sea folk to harvest electricity at several times their current income. Now, the long-term solution we're looking at does not look a great deal like the one we're doing for testing. It's going to be a submersible solution. 1 unit per boat is not viable due to weather and scalability. We plan to operate 10 submersible 5 kilowatt units per boat. That's 150 megawatts with a market value of 80 million Philippine pesos per day, divided out over about 9,000 people. And you'll notice that our pods here, which is going to be containing most of the equipment, look a lot like they're made out of PVC pipe, which is because we plan on making them out of PVC pipe. 24-inch Schedule 40 PVC makes a pretty good watertight container for these sorts of things, and it's easily available without having to make custom molds. When you divide this money out over the number of staff, we come up with about 8,500 pesos per day per person. If we deduct expected equipment costs and operating as a cooperative, with 2/3 of profit going to the operators, we expect each person to earn about 1,500 pesos a day compared to their present 250. Even if we're off by that, we're looking at several times their daily income to boost the island economy. The Indigenous Power project is only a part of what OroAzul has been investigating. We're looking here at 2 of our deep blue water solutions. The one on the left is attaching large-scale collectors off of oil rigs. That video is upcoming. The one on the right is attaching these into open water large ships on the scale of small container ships. And we already have a presentation on that technology. I think we all should be focused really on the indigenous power generation solution. In order to achieve true sustainability, we need to bring the standard of living of these peoples closer, lift it significantly, and as that money comes in, one of the first things these people ask for is better education. They have the educated people to run the schools already. It's just a matter of, can these people make enough income to pay for the schools they deserve? We raise the education for the girls, and their fertility will decline, and that will boost their standard of living even further. And that will help us all get planetary population back within carrying capacity. We are looking at basically virtually free energy from the entire ocean, 2/3 of the Earth's surface. Dark Sky's pending patents are for devices using the pumping action common to all the designs we've been showing in these animations. We own the concept for the free flow ocean pump without cylinders. We have not filed patents on any of these particular collector shapes. We expect them to change a great deal. We expect new ones to be invented. I personally feel that patenting these shapes would be a waste of time and money. What we have patented is the concept of using an opening and closing drag collector, pulling a cable, driving a generator to collect energy, opening that collector and using that motor generator to drag the collector back to the starting position and repeating that as a cycle. That is what our device patents cover. Our cost estimates, similar to the one we did more formal engineering estimates, but it's similar to the envelope estimate of looking at it compared to a portable generator, show that over the lifetime average, these devices can generate energy at a cost of on the order of 1/100th of a US cent per kilowatt hour, compared to 5 cents to 11 cents per kilowatt hour for common generation methods. So I would think that pretty much qualifies as virtually free energy. Virtually free energy, hundreds of kilometers from shore, is of little to no value. The next piece of OroAzul's technology, which is also patent pending, describes how to get that energy to shore at costs from 4.5 down to half of a US cent per kilowatt hour. Our solutions begin with off-the-shelf batteries transported by container ship to deep water, high-pressure electrolysis of water. This part of OroAzul doesn't have eye-catching graphics. It's a lot of numbers, chemistry, and physics that reduce down to this chart. And we'll be making a presentation strictly on the cost estimation and economic estimation that's backing up this video, but that video is in the future. The lower bars on this chart show the most common forms of power generation today. We didn't put we have the average generation cost down at the bottom of about 11 cents per kilowatt hour. That includes nuclear, oil, and coal. And then we have the current most dominant sustainables. And then above that, we have the natural gas value from around 2019 when it was at its lowest. It's actually higher than this now. And above that, we have the OroAzul technologies, the most expensive of which is shipping electricity by deep cycle lead acid batteries by container ship. And this figure is computed by shipping it across the ocean. Shipping it through pods locally within the Philippine Islands is much lower, so we can expect maybe a little bit lower than 4.5 cents per kilowatt hour. And then we also have a method using compressed air and compressed hydrogen, and we also have one using the up-and-coming sodium glass battery technology, which gets us down to our half cent per kilowatt hour. We are proposing beginning with the off-the-shelf batteries housed in watertight pods that can be towed to shore based on catalog prices and a life cycle of 2,000 cycles. Deep cycle lead acid batteries yield roughly 4.5 US cents per kilowatt hour. This is the battery tech most common in wind and solar farms at this time. While lithium battery technology has higher energy density and lower weight, making it ideal for vehicle applications, it costs more and has shorter life due to dendrite formation. Many people have gotten on our case, oh, why are you using lead acid? Oh, everybody's using lithium. Well, if you can find a better, cheaper battery tech on a total life cycle cost, either doing from government subsidies or producer discounts or so forth, well, you can use those batteries instead in the same application. And if your battery cost is lower, that will pretty much divide our generation costs by the cost of your batteries, because the bulk of our cost is actually in the batteries themselves. We are proposing using deep water high pressure electrolysis, DWHPE, tech for phase 2. DWHPE is based on existing HPE, which is based on utilizing the extremely high pressure at great depth underwater to produce free compression of the hydrogen and oxygen produced by electrolysis. Most of us watching this are familiar with electrolysis, at least to the extent of what we did in school. You take a little beaker of water, you take a battery, you take a couple of wires, you poke them in the water, little bubbles come off. Some teachers will actually grab a little match and put it next to the hydrogen side, and you actually see the hydrogen burning as it comes off the water. Ooh, really cool demo. And in the more advanced classes, they will cover the actual energy equations of how much energy you have to put in through the electricity in order to crack the hydrogen into the oxygen and hydrogen. And usually about 15% of that energy is lost. But that equation does not have a pressure term in it, and that is not a mistake. It turns out that the power to crack the water is independent of the pressure the water is at. And we'll be doing a video on this subject alone. If you perform the electrolysis at great depths, at 500 meters, the pressure of the gases is about 50 bar, 50 atmospheres. That's roughly the pressure of the power stroke on your car engine. When your engine squirts gasoline into the piston and the spark plug ignites it and explodes, the pressure of that explosion is about 50 atmospheres, and that's what drives your car. So we're talking about producing pressures high enough, equal to the pressures that drive your car, from electrolyzing water at depth under the ocean. If we take that depth lower, if we take it below 900 meters, with adiabatic heat exchangers, the gases can be liquefied as they expand. So using WHPE as a fuel source, there are many ways to use highly compressed hydrogen for fuel. What we recognized is that when the gases are expanded adiabatically from these high pressures, they become so cold they can be used to drive existing heat engines in reverse. Endothermic heat engines. These endothermic heat engines can use the ambient heat from the atmosphere, the ocean, waste heat from air conditioning systems, to boil or expand these super cold gases to perform work before the hydrogen is burned. It's actually a power source all by itself. This is cryogenic cogeneration. In addition to all the water currents and tidal activity we had in the earlier part of the presentation, the Philippines also has access to, extremely deep ocean depths very close to shore. One of our collaborators, people we've been discussing with in Edinburgh, pointed out and was quite shocked to learn, oh my God, you've got 6,000 meters of water depth within 13 kilometers of shore. Yes, they do, here in the Philippines. So where we're working, the red dot of Bantayan Island, just to our south, at the other end of the Tanon Strait, we have 600 meters depth. And the Sulu Sea and the abyssal plain on either side are running about 4,000 meters. And that large, dark band on the right-hand side is the Philippine Trench, which is going down to 6,000 meters. So it is not too difficult to envision generating electricity from the interior of the islands, running it by electrical cable over to the shore of the islands, running it down through one or two major trunk lines down to the electrolyzers, and producing massive amounts of highly compressed hydrogen and liquid hydrogen suitable for export. This is one of the bases of our ocean energy cycle. Dark Sky's ocean energy cycle is a patent-pending process that is similar to other power cycles, such as steam, Otto, diesel, Stirling, and Brayton. Engineers recognize these names. Anyone in the mechanical engineering curricula, have seen these, and we all know what these means. But most outsiders, common people, ordinary people who hadn't suffered through all the engineering courses, don't recognize some of these names. Otto is the name of the German engineer who developed the four-cycle gas engine, so most of your cars run on the Otto engine. Some of your cars and most trucks and trains and so forth and ships run on the diesel engine invented by Mr. Diesel a long time ago. Mr. Stirling invented the ideal, most theoretically efficient engine cycle, which is very rarely used because it's a mechanically complex cycle. But it is used in a few places, and there are often attempts to revive it and make it usable. I know NASA has used them on occasion. And then there's the Brayton cycle, invented by a fellow named Brayton. Brayton is the cycle that powers jet turbines for jet aircraft and helicopters and tanks and trains and high-speed ships. So this process is similar in concept, and it can be summarized as collecting energy far from shore, converting it into a transmissible form, and shipping it to shore where it's used. But the actual physics and engineering fills a few pages and documents when you compress, when you decompress, how you decompress, and it amounts to an ideal gas chemical power cycle of how you collect energy from the ocean far, far away, store it, and bring it to shore. OroAzul's tech makes it possible for the Philippines to generate and transport enough sustainable energy to become the sustainable Saudi Arabia of the future. What Dark Sky has now, at this point, we have theoretical concepts, patents pending, and enough confirmation by qualified reviewers to be confident Dark Sky's OroAzul tech has the potential to power the world for centuries to come at lower cost than any other method in today's marketplace. We even have agreements with local government to perform live field testing. Here's an aerial photo of the southwest peninsula on Bantayan Island, and you can see Bantayan Municipality at the top of the image. Circled in red at the lower left quadrant are some offshore islands. On these islands there are a few families of indigenous fisher folk living here in very beautiful but primitive conditions. They have no electric grid, they have no cell service, they certainly have no internet service, and their only source of electric power is running off of portable generators fueled by gasoline. We have an agreement with the senior municipal councilors of Bantayan Island, Bantayan Municipality on Bantayan Island, who fortunately were re-elected in the last Philippines election last week. And the agreement is that they would like us to proof of concept our units on these remote islands so they can ditch the portable generators. If we are successful in doing that, they will then abandon their request to get a permit to run an undersea cable from the neighboring island to power this island. I gather that request has been pending for a few years, shows no sign of moving forward anytime soon, and it's kind of local expectation that it could be another 10 years before they get a permit to run a cable to provide the 7 to 8 megawatts of power that the island uses. That restriction is because all of the water around Bantayan Island is in the middle of a very large marine sanctuary. And that marine sanctuary exists to reduce the fishing in the area, to bring back the fish stocks, which are coming back, the corals are coming back, but in that interim, we have those 3,000 unemployed boat crews of very skilled water people, and there are a few women in the crews as well, just waiting to go to work doing this, making as much more money than they did when they were fishing. So, as you might imagine, the counselors on Bantayan are really quite excited about getting this moving forward. But like everyone else in these sorts of things, we are short of funds to make this all happen. So what Dark Sky is seeking, we are struggling to build minimum size demonstration units funded by our founder, yours truly, me, and small donations from a few true believers. We are seeking roughly $1 million in initial R&D funding to produce, test, and document technology demonstrators. Why roughly $1 million? Well, we have found there is a wide variation in what people consider adequate proof to get funding. We've spoken with engineers who regard hanging a collector off a bridge adequate to convince them. We have met with a speculator or two who demand 8 months of at-sea operations under sea conditions with videos and proof of regular power delivery to demonstrate adequate proof. And academicians, professors at universities who require volumes of academic journals, computational fluid dynamics, laboratory testing, having published in numerous journals before they're satisfied that we have adequate proof. And each of these has a different cost, leaving the choice to the funders of what constitutes your version of adequate proof to move forward to the next stage of funding, and each of those has a different cost. So $1 million will allow us to do what we regard as minimum proof of concept testing. How will your donation be used? Our research has shown that no publicly traded company is able to assure sustainability and ethical use of this technology. That's probably worth a video all by itself. Only a non-profit NGO with an environmental mandate can assure this technology and its revenue is used properly to heal our planet and achieve sustainability. We are in the process of incorporating and getting a 501c3 status for such an NGO, which we have called Terra Protectori, Earth Protectors in Latin. When that comes in and when the 501c3 is approved, I will be transferring all of these patents and intellectual property to Terra Protectori, who will be overseeing use and licensing the technology to industry. If all of that is successful, your donation will be aiding us in creating a self-funded environmental NGO owning the most quote-unquote profitable energy sources in history. If we are successful in replacing fossil fuels and putting them in their grave where they belong, we will then be the world's largest energy producer with revenue streams on the scale of the oil-producing countries. And it will be owned by this nonprofit NGO. Any revenue from that will be then redirected by that NGO toward environmental remediation. So that's where your donations would go if you choose to make them. Well, that's a big bite. All of OroAzul is a big bite. I expect that this will be taking several videos of this sort and a few live presentations. But this concludes the Indigenous Ocean Energy presentation by Dark Sky Innovative Solutions and myself, Bob Tipton. If you wish to contact us, please reach out at info@darkskyinnovation.com, and we are looking forward to hearing from you.